Okay, in the last part of our graphing videos, we looked at how to make time series plots. In this clip, I want to look at how to make a histogram. So how can we plot out the distribution of a data series? Now, last time we used a function called gdplot, which helps us make quite neat graphs. I think for the histogram, I'm just going to use the base R approach because it's a little bit simpler, and if you want to then try something more complex, you can do that later, but let's just look at the more basic approach for the moment. I've changed the data set which I'm working with, and I've already read it in, so you don't have to watch me do that. I have Standard and Poor returns over time. I have Dell stock price returns over the same periods of time. Now, ordinarily, stock market returns should be normally distributed. So, in fact, we can make a test of this and we can plot the histogram. The syntax for a histogram is HIST. Then in brackets, I need to state the name of the variable that I'm interested in. My data frame is called Dell, and I'll plot an individual stock price return, which is Dell return. So Dell, dollar, Dell return. And if I press enter to that, let me just move that for you, you'll see I get a histogram. Looking at the histogram, I see it's not quite normal. Just by looking at it, if I really wanted to test normality, I would prefer to do a Jacques-Barré test, or I would at least want to calculate the skewness and kurtosis values, but just by eyeballing it, which isn't always the safest way, it's a little bit off normal. It's got quite a high right shoulder, bearing in mind that's the 0 point. Okay, I'm not intensely happy with the histogram which I've got. I think the first thing I'll try and do is increase the number of breaks in the histogram, just to see if by making the category or the bin widths a bit narrower, it changes the appearance. So I'll run another histogram with the same data. This time I'll then go comma space and add an argument for the number of breaks. Breaks equals, and well, in this one, 4, 5, 6, 7, 8, 9, it's given me 9. I'll tell you what, I'll put 20 in just to produce a big difference. You see now I've increased the number of bins I have. The bin width is narrower, and you see again I'm still seeing a lot of right hand shoulder, but you see it's also not quite as smooth as you may expect. Given I've got 146 data points, I wouldn't expect perfect smoothness in the distribution, purely in line with the central limit theory. Maybe it actually looked a little bit nicer when I didn't have 20 breaks in. One last thing I'll show, because I don't want to talk for too long, is there are some arguments that I can pass which allow me to make this look a little bit more visually nice. I'll pass the breaks argument again, but I'll pass it only for 10, just to produce something that looks a little bit more visually interesting, but might not be so easy to interpret. That's a trade-off you can control. I see on the x-axis I've got del, dollar, del return. That's not very nice, so I'll pass the argument x lab and just follow the auto prompt. The label text I need to put in speech marks, I'll just call it, maybe not price, I'll call it return. It's a bit more accurate, comma, space. I can also change the title at the top if I pass the argument main equals, and then I'll just call mine histogram, but you can decide what the correct title should be. To make the grey colour looks okay, but if I use the argument col, I've got two choices. I could actually use hex colour codes to pick an exact colour. If I just use speech marks and put a rough colour, R will approximate the colour, and you see I've got something which is visually a bit neater. I can change the colour, I can change the labelling to produce something that actually looks quite neat, and I could paste that in a report, no problem. Let's leave that one there.